Hi guys, I hope you're good. So today it's grade 11 cycle geometry, few questions specifically for theorem number 1. In the diagram below, PQ, ne? PQ, this line, PQ, this line PQ, this one is the chord of circle O. Is the chord of circle O. PQ is a chord. Do you remember what is a chord again? Yes. Now, if PQ is a chord, then OR is perpendicular to PQ. OR, this line, OR is perpendicular to PQ. This 90-degree angle here. And perpendicular means 90-degree angle. Okay? And QR intersect PQ at T, which means QR, PQ or P to PQ and O is perpendicular to PQ and QR. Ne? Okay. One is 90-degree. Yeah, 90-degree, 90. Oh, 90. Yeah. Yeah. If the radius of the circle is 13 centimeter, radius of the circle is 13 centimeter. Okay, radius. What is a radius? Radius is a line from center to the circumference. Okay, which means this line from center to the circumference is radius. OQ is a radius, 13 centimeter. And you guys, Bible, OQ 13 centimeter. Even I can literally construct OP because like a radius is a line from center to circumference. 13 centimeter. And whatever from O to the circumference, from center to circumference, 13 centimeter. This line, OR, radius. 13 centimeter OR, 13 centimeter from here to here. This whole thing. OT plus TR equal to 13 centimeters. From O to the circumference, radius. Guys. As long as that line touches the center, as long as that line starts from the center to the circumference, it's a radius. Thank you. I hope you're good with that. Then PT 12 centimeter. PT 12 centimeter. What is PT? Where is PT? Here's PT. 12 centimeter. 12 centimeter PT. Sharp. It's fine. Calculate the length of PQ. What a PQ? Which means line. What a PQ? Which means PQ. Okay. PQ. What are this length here? PQ. And length here number B. What the length here? PQ. No guys, not length of PQ. I think there's a mistake here. In the following sketch, O is the center. Which means in the following, O is the center. Okay. Determine with represents the angle marked A, B, and C. Okay. So you can see circle with center O, and we've got this angle here, 25 degrees. This angle is here, is part of this one. Okay? Yes, that angle 25 degrees. You can see it here, guys. Then now, we talk about A, B, C. But now we can see that this thing it has got theorem number 1 in it, which means the whole thing, this triangle here, has got theorem number 1 tactics. Why I'm saying that? Because I can see these two. And you know what's about this thing is a chord. This thing, it's a chord. This thing is a chord. This one. It's a chord. Level. It's a chord. If this line is a chord and they bisect one another, which means this one bisect this one, they're equal into length. If I say the two lines bisect one another, it means they're equal in length. Okay? If these two sides bisect one another, according to theorem number 1, the theorem number 1 says that if the line drawn through the center of a circle and bisecting a chord, if line drawn through the center of a circle and bisecting a chord, which means if it bisecting this chord, then this chord is perpendicular to the chord. This line. If the line thrown through the center, which means if the line thrown through the center, like this line again, if this line thrown through the center and it bisects this chord, equal in length, therefore that chord is perpendicular to that line. We've got 90-degree angle here. 90-degree angle here, guys. I hope I'm clear. Come on, C is 90 degrees. Let us write it down. Already we know what is happening here. C equal to 90 degrees. Why are we saying that? Go back to theorem number 1 and look out for the reason. I've just said the statement for theorem number 1. When I go and look out for the reason, if I say C equal to 90 degrees, you must know the reason why. Here's the reason. Radius bisect chord. This is the reason. I hope I'm clear. Radius bisect chord. I hope I'm clear, guys. Let us go to the next one. We've got 90-degree angle there. Sharp. Now, which angle can we find again? I can see that I've got 25 degrees angle here. Okay? And there's a theorem that talks about angles in the same segment. Go back to and look out for the theorem that talks about angle in the same segment. What does that theorem say? It says that, let me just throw something here. Now, I want to go back to this theorem, guys. Now go back to this theorem. This theorem says that if you have got this kind of arrangement, therefore we've got angles in the same segment are equal. Come on, so angles subtended by the same chord are equal. Which means if you've got I can have something like this here. I can say this line is a chord. This line, I can say this line is a chord. Which means if this line is a chord, therefore angles subtended by the same angles made by the same chord, or angles subtended by the same chord, and what are equal. If this chord it makes this angle, and again this chord again makes this angle. These angles are equal. These two angles are equal. Why? Because they are made by the same chord, or they are subtended by the same chord, or these two angles are in the same segment. That's how this theorem talks about. Now let us come back to this question. I can see that I've got some sort of this type of arrangement here. Here is this type of arrangement. Now let us check this arc. What's an arc and chord? Sometimes an arc can play the same role as a chord. Yeah. So let me just say we have an arc. This one, this arc level. Now this arc, it makes up two angles here. I'm going to show you these two angles. It makes up this angle. Look at the color yellow. This angle, it makes up this angle. This one, that has 25 degrees level. This angle, this one, that has 25 degrees in it. And again, this arc with the purple color, with this color, it makes up which angle? This one. Let me show you. This one. It makes up this angle. Just like this one and it made up this one. It also made up this one. So this arc, it makes up this angle. It also makes up this arc again. Makes up which one? With this angle. This angle and this angle are equal. Why? Because they're subtended by the same chord, or are angles in the same segment. Angle A equal to 25 degrees. Why? Angles in the same segment. Yeah. A is equals to 25 degrees. Why? Angles subtended by same chord. Or you can say angles in the same segment. It's a choice. Once you've got 25 degrees here. Liable, guys. We've got 25 degrees on that one. Now, rather B. Here's our B. We want B. How can you find B? I can see that we have a triangle here. This triangle, this one. I have got this triangle here. This triangle has got two known angles, which is 25 degrees and 90 degrees. And B is unknown. Therefore, as per the rules of triangle, or as per the properties of triangle, it says go to angles inside the triangle, they add up to 180 degrees. If I've got two known angles and one unknown, I can find that one unknown through by saying that angles inside the triangle, they add up to 180 degrees. They add up to 180 degrees. You can have something like this. Hurry, angle A plus angle B plus angle C equal to 180 degrees. Why? Reason to angles of triangle. Angles of triangle. Couple angles inside the triangle add up to 180. You can say anything that has to do with angles inside the triangle that add up to 180 degrees. What is angle A? We know it's 25. What is angle B? It's unknown. What is angle C? 90 degrees. Therefore, 180 degrees. Therefore, you take this 25 and this 90 to the right and say we are left with angle B on the left. Then we're going to have 180 minus 90 minus 25. Therefore, you just do algebra here. 180 minus 25, 180 minus 90 minus 25. Therefore, angle B is going to be equal to 75 degrees. Hope I'm clear on that one. Hope we are clear. Let's go to the next question. Here's the next question, guys. Let's read the statement. You can write down everything here. Now, it says that in the diagram, O is the center of the circle. In this diagram, O is the center. Very important. Now, chord AC, this chord AC is perpendicular to radius OD. Okay, this chord AC with the yellow is perpendicular to OD. The radius, OD is our radius. Remember, radius is the line from center to circumference. OD is a radius, OA is a radius, OC is a radius. When they are made, you call them the radii. That's very important, guys. Yeah. All these three sides are radius. You must understand that. Then they say that they are perpendicular to angle B equal to 90 degrees. It means these three angles called for surrounding B equal to 90 degrees. What do you remember about that? I get the told us AC is our chord. What do you remember about figure number 1? It says if you've got 90 degrees angle here, therefore AB and BC will bisect one another. Once more, they're going to be equal in length. AB equal to BC in length. Hope you are clear. Then they are saying that OB equal to 2x. OB equal to 2x. OB equal to 2x, okay. And AC equal to 8x. AC comes on length from A to C equal to 8x. AC, this the length from A comes on this chord equal to 8x. But we said that they bisect here. Comes on they share the length. Which means AB and BC, they wanna share this 8. When you share this 8 into 2 equal parts, we say AB equal to 4x and BC equal to 4x. And 4 plus 4 is 8x. That's one length of AC equal to 8x. Why? Because AB and BC is going to be 4x plus 4x, which is going to be 8x. Once more, AB and BC is going to share this 8x into 4x and 4x. When you add them, it's going to be 4x plus 4x equal to 8x. Hope I'm clear on that one. Which means the question says that you must show that the length of BD is 2x bracket square root of 5 minus 1 close bracket units. Come on, man, you must show the length of BD. But where is our BD? This one. You must show the length of this line equal to that one, 2x bracket whatsoever. Now, how can you show it? Equal to, how can you show that the length of BD equal to 2x square root 5 minus 1? How can you show that? Now, BD is part of OD, and it's OD ki radius angere. I give what's about OA is equals to OD is equals to OC in length. In terms of the length, OA is equals to OD equal to OC. Why? Radii. Remember, singular, the radius. When they are in plural, the radii. When they are many, they are called radii. When it's one side only, there is a radius, you call it radius. Are you guys understanding this thing? Now, governing BD is part of OD. We already have got the length of OB, which is 2x, but we don't have the length of BD. How can we find BD, guys? How can you find BD? The only way to find BD, we already know BD is part of OD. And OD, this line OD, is our radius. Which means if we can find the length of the radius, we'll be able to find the length of BD. Surely we'll be able to find the length of BD. Let us find the radius. Radius can be found in many ways. I can find the length of OA because I've got 4x and 2x Pythagoras. I can find the length of OC because I've got 3x and 4x. Which means these things are the same. The length of OA and the length of OC and the length of OD are going to be the same if I can find any of the two. Now, let me just find the length of OA. OA squared is equals to, and we're looking at triangle AOB, this triangle. And we want to find the length of OA. We only use Pythagoras if we've got two known angles, two known sides and one unknown side. That's very important. We've got two known and one unknown sides. OA squared is equals to AB squared plus OB squared. Why? Pythagoras. Very important, Pythagoras theorem. Now, what is the length of OA? It's unknown, It's fine. What is the length of AB? Is bracket 4x squared plus what is the length of OB? Is 2x squared. Now, if you simplify this one, bracket of 4x outside is square. Come on, this is for this this exponent is going to multiply the exponent of 4, which is 1, and the exponent of x, which is 1. Which means this 2 times 1 is 2, 2 times 1 is 2. It's about 4 squared, which is 16. And x, it's about 1 times, which is x squared. Where does this come from? Plus this 2 again, this exponent is going to multiply the exponent of 2 inside bracket and the exponent of x inside bracket, which is 1, 1. 2 times 1 is 2, 2 times 1 is 2. 2 squared is 4, and exponent of 1 of this x is going to be 1 times 2 is 2. Then equal to OA squared. We want to remove this squared. We do the square root on both sides. Square root on both sides. Square root on both sides. OA is going to be equal to, sorry. We're going to have OA is equals to, I just did like terms. 16x squared plus 4x squared is equal to the square root of 20x squared. Then what is the square root of 20? The square root of 20 is going to be, when you put 2 by the square root of 5x. 2 by the square root of 5x. I made a mistake here, guys. So And you want to say, you cannot I cannot just find the square root. It's gonna be wrong. I need to add the like terms inside the bracket. I can only find the square root of something if that thing is alone. It means if you've got one term inside the bracket, but here you've got two terms, 16 squared plus 5 squared. These are two terms, so I cannot find the square root of each. I need to combine them, or I need to leave it like that. If they cannot become, if they're not like terms, I leave it like that. But right now these are like terms because of this x squared. Because of this x squared, it means 16 and 4 are like terms. Therefore I'm going to add them. It's going to be 16 plus 4. It's going to be 20. Then I bring down this x squared here. Then I just find the square root of 20. What the square root of 20 is 2 square root of 5. Then this squared here is going to actually be removed by this root sign. It's going to be left with x only. Hence we've got x only here. Hope I'm clear. Now let's come back here. Now let's come back to the diagram here, guys. Now from the diagram we got OA, which is 2 square root of 5x, 2 square root of 5x, 2 square root of 5x. Very clear. Label. Now I can read it. They are equal. OA, OD, and OC are equal. Okay? Now, very simple. Actually, mathematically, you know, it's right to say that OD, which is this OD, this line, is equals to OB plus BD. Come on, Tamang. The length of this radius is equals to OB plus BD, which means you add the two, this one and this one here. Already added. Already left here OB, which is 2x. Which means OB is 2x, then OD is 2 square root of 5x. Come on, so get the length here, BD. Yeah, this one, what the length not BD. Let's write it down here. Let's write it down here. Alright. OD is equals to OB plus BD. What is length of OD? Length of OD is 2 square root of 5x equal to what is the length of OB? Is 2x and OB yona. Then what BD and that's very important. Then I'm going to transpose this 2x to the left. So I'm going to have 2 by the square root of 5x minus 2x equal to BD. Label. Then therefore BD is equals to 2 square root of 5x minus 2x. And can our answer and you return even 20 2x bracket square root of 5 minus 1. 2x bracket square root of 5. Remember that 2x and yes. How do I make that to be in that way? Hurry. Let me just see. Here we've got BD is equals to 2 by the square root of 5x minus 2x. Now you can end it here, but you can continue by saying, okay, I've got these two. Which means I can this x put it like this: 2x square root of 5 minus 2x. Still the same thing, and I can take out this 2x inside as my common factor. If we've got minus or plus in the middle, we can take out the common factor, which is 2x. Therefore, we're gonna take out this 2x outside the bracket, 2x, and you're gonna be left with, if you 2x divided by 2x, you're left with square root of 5. 2x divided by 2x, we're left with minus 1. There's your answer for BD. Hope I'm clear. We are clear, guys. Yes. The next one. The last one, guys. The last one, it says that in the diagram, O is the center of circle ABD. Circle A, B, and D. And get sharp. F is a point on chord AB. F is a Now they're telling you this is a chord. AB is a chord. AB is a chord. They're telling you that AB is a chord, okay? Such that this line DOF is perpendicular to AB. Kana say when the lines are perpendicular, what do we say? If they're perpendicular, it means length here AF is equal to length here FT. They bisect one another. That's what we said about if the lines are perpendicular to one another, according to theorem 1. Very important. But when AB is equal to FD, AB equal to FD. Now my length here AB is equal to length here FD. Now, which means length from here to here equal to 8 centimeter, and length from D to F equal to 8 centimeter now. Very important. Okay, very important, guys. Yeah, sharp. Now Babaro and OF equal to X. OF equal to X. Here's OF equal to X. Determine the length of the radius of the circle. Very important, radius of the circle. Let us find out the radius of the circle. I just radius line from center to the circumference. Can you please guys highlight the radius on the circle? Can you guys please point out or highlight radius on the circle, or the radii? In plural, the radii, singular, the radius. Can you please just highlight them? Let me just highlight them for you. If you are done, let me just show you what are radius of radii on a circle. Here's our first one. The second one from O to B, and the last one is from I can literally construct OA. Very important, guys. Now, the length of the radius. I can find the length of OA, I can find the length of OB, I can find the length of OD. It does not matter as long as it's our radius. Now, that's very important, guys. But I think this one is very simple, because they told you AB is equals to 8 centimeters. Once my length from A to B equal to 8 centimeters. Okay? It means AF and FB, which means AF and FB, they want to share this 8 into 4 and 4, which means about 4 here and have 4 here. We have 4 centimeter, 4 centimeter outside, and we've got X as our OF. And you can find any length of radius between OB, OA, and OD. It does not matter as long as that line starts from the center to the circumference. It's a radius. How about then? Now we've got this triangle. Let us check this triangle. I can see that I've got 2 lengths. You can check triangle OAF and triangle OFB. I've got length of OF and length of AF. On this triangle, I've got length of OF and length of FB. It's very simple. If that's the case, then it's very simple to find the length of OB and the length of OA. I can use Theorem to find the length of OB in this triangle. In this triangle. How about the length of OB? It's OB on the radius. But before that, you need to write it down. Whatever that we've been saying, we need to write it down. Alright. OA is equals to OB is equals to OD. Reason like radii. They are more than one, the radii. Therefore, from this triangle here, OFB, and this triangle, I can say that, okay, please check the triangle. I can say that, okay, OB squared is equals to OF squared plus FB squared. Why? Pythagoras. Remember, Pythagoras qualifies you to use it if and only if you've got 2 known sides and 1 unknown. And if and only if that triangle is a right angle triangle, you can use Pythagoras theorem. Very important. OB, we don't know OB, okay? We leave it like that. What is OF? Is x squared. I get x. OF is x again. then another squared obviously, plus FB, 4. And they share this 8. Very important, 4 squared. Therefore, OB OB squared x squared plus 16. Then I introduce the square root both sides, square root. Then OB is equals to x squared plus 16. Yeah, that's how it is, guys. Yeah, that's how it is. This is the length of the radius. This is the length of radius. Radius, therefore, radius on again, square root of x squared plus 16, square root of x squared plus 16. Whatever. So you have answered the question of finding the radius of the circle. Thank you very much, guys. I hope you are good. Until the next video.